Hi, my name is Fariehah, Binti and Amran with metric ID AN190164. My supervisor is TS Dr. Binti Mansoor. I'm from Faculty of Engineering Technology, Department of Chemical Engineering Technology, with the title of my PSM is Preliminary Assessment on Microencapsulation, Efficiency of Pipette with xanthan and sodium alginate using spray drying. For the abstract, the pea bread has high nutritional value, hence it makes a good functional food. However, loss of nutritional value of a pea bread occurs during ingestion, if not if the pea bread is not protected. Therefore, the purpose of the study is to microencapsulate the pea bread and its content with food-grade biopolymers, namely xanthan gum and sodium alginate, to emulsification using spray drying method. From this study, the moisture content recorded is 20.6% and the pH is acidic. The microstructure of the pipette is roundish with slightly smooth surface with average particle size of 4.42 micrometer. The best temperature and the percent of polymer is 150 degrees Celsius with 0.25% of polymer used for the microencapsulation of the pipette using the spray dryer. For the 0.25% of the polymer, the viscosity range is 0.011 until 4.09 Pascal second. The functional group that found in the pipette are oxygen hydrogen bond, carbon hydrogen bond, and chemical carbon oxygen double bonds. This In this study, it can be concluded that depending on the biopolymers and temperature of the spray dryer, the bee bread can either be partially or fully encapsulated by using the combination of emulsification and spray drying technique. For the introduction, for the research background, the microencapsulation of bee bread with food-grade polymers, namely xanthan gum and sodium alginate, through emulsification using spray drying method. The problem statement in this study is underexplored pea bread has high moisture content that promote the growth of microorganisms. Thus, emulsion and spray drying methods are used as alternative for the conventional preservation method. The objective of this study is to assess the physical-chemical properties of pea bread. Second, to evaluate the microencapsulation efficiency and the functional group of the pea bread with two different polymers at different temperature. And the third is to determine the percentage of polymers suitable to be used to spray dry the microencapsulation of the pea bread. For the scope, the pea bread was collected from the Nyali Chicken Farm located in Malacca. The microstructure of pea bread and microencapsulated pea bread were assessed by scanning electron microscopy (SEM) and the functional group by Fourier transform infrared FTIR. For the literature review, the pea product is honey, pollen, royal jelly, propolis, and bee bread. The bee bread is fermented variation with better nutritional content. The bee bread is fermented variation with a better nutritional content, full addition of mineral, vitamin, and etc. The benefit of the bee bread is from the antioxidant activity, antimicrobial activity, and prebiotic properties. The polymer has three types, which is natural, synthetic, and semi-synthetic. For the encapsulation method, the emulsification and coagulation are the method of the encapsulation. For the drying technique, there are spray drying, freeze drying, vacuum drying, and etc. The methodology for this study is firstly the sample collection from Nyali Chicken Farm located in Malacca. Then we will measure the uh, moisture content by taking the weight of the pea bread dry in the oven until the weight taken is constant. Next, the pH value After that, viscosity, then emulsion of bed with polymers to mix the bed and polymer dissolve in this water. Then spray drying process to dry the microencapsulation of the bed with polymers, followed by microstructure by scanning electron microscopy (SEM), the functional group by Fourier transform infrared FZR. Then at the end is statistically analysis, which will use uh, prism and image JSON. For the result and discussion, the graph shows the drawback of the H-ethanol pipette. This drawback that calculate every day under the weight taken is constant are used to calculate the moisture content. The moisture content of the pipette in this study is 20.6%. The picture below shows the microstructure of dried pipette, microstructure of microencapsulated pipette with xanthan gum, and the microstructure of pipette with sodium alginate. From the figure, we can see that the pipette microstructure of the pipette is roundish with smooth surface, with slightly smooth surface. Then for the xanthan gum, we can see the pipette is coated by the xanthan gum. However, it is only partially coated since there is still pipette that the particle of the pipette that we can see. For the sodium alginate, we can see that the polymer sodium alginate are fully encapsulated the pipette. From this, we can see that sodium alginate is better in encapsulate with pipette compared to xanthan gum. The graph shows the productive of spray-dried microencapsulation of pipette with polymer at different temperatures, which is 150 degrees Celsius and 170 degrees Celsius. From the product width, we can see that the product width of microencapsulated pipette at temperature 150 degrees Celsius has higher production yield compared to 170 degrees Celsius. Hence, the temperature of 150 degrees Celsius is chosen to microencapsulate the pipette due to higher production yield compared to 170 degrees Celsius. For the graph below, it shows the spectrum of microencapsulated pipette with polymers at different temperatures. From the graph below, we can define there is presence of NH and CN1, which is amides and amides. The peak range are found at 875.924 per centimeter, which corresponds to NH of amide groups, while the first graph shows the viscosity at different percentage of xanthan gum. From this, we can see that the concentration of 0.2% of xanthan gum is not significant. Rather, the 0.1 concentration followed by 0.25, 0.50, and 0.5% show the significance of the percentage of the viscosity. Hence, we choose the 0.25% of xanthan gum was chosen due to the production cost, in which the increased percentage of polymer means the cost production will be higher, and the 0.1% of xanthan gum are not chosen due to the solution will be too watery and the efficiency of the spray drying will be lower than 0.25%. The next graph is the viscosity at different percentage of sodium alginate. From this, we can see that the 0.5% of sodium alginate is not significant. to the 0.33, 0.33, 0.25, 0.2, and 0.1, which is significant compared to 0.5%. In this, we also choose, in this, the 0.25% of sodium alginate was also choose due to same reason with the xanthan. Next, the graph shows the product yield of spread rate microencapsulated of beef bread with polymer at different percentage of polymers. From this, uh, the the percentage of polymer, the 0.25% of polymer was chosen due to the higher product yield compared to 0.1%. The figure below displays the spectrum of microencapsulated wheat bread with xanthan and sodium alginate with the percentage of polymer 0.1% and 0.2%. The spectrum of the microencapsulated wheat bread with xanthan exhibits similar spectrum with the microencapsulated wheat bread with sodium alginate at a temperature of 150 degrees Celsius. Generally, the peak range of 3,500 per centimeter shows the composition of alcohol, amine and silicon compound. The bond of C double bond O, NH2 and NH was identified in peak range of 1,600 per centimeter. The range of peak at 100 per centimeter displays the composition of alcohol, amine and silicon compounds. To complete the study of the preliminary assessment on microencapsulation efficiency of beef bread with xanthan and sodium alginate using Fariehah is the study is achievable. The H bread uh, has the moisture content that is higher than the moisture content recorded from the previous study. It also has a pH value higher than the previous than the compared to the past research, but it is still considered acidic. From the evaluation of on the microencapsulation efficiency at different temperature, micro at different temperature, microencapsulation of lipid produce higher product yield at temperature of 150 degrees Celsius compared to 170 degrees Celsius. Therefore, the microencapsulation of the lipid is more efficient at the temperature of 150 degrees Celsius. Next, the assessment on the microencapsulation efficiency of the lipid with xanthan and sodium alginate at different percentage of polymer show that 0.25% of the xanthan or sodium alginate is the most suitable to undergo the spread drying. Hence, microaggravation of the beef rate with 0.25% of xanthan or sodium alginate through combination of emulsification and spray drying method at temperature of 150 degrees Celsius will provide higher microencapsulation efficiency. The suggestion that from this study are the further analysis on the physical chemical properties of the pipette and the antioxidant activity with thermal stability analysis towards the microencapsulation of the pipette. That's all from me. I will end this presentation with thank you to everyone.